Okay, evaluate each limit. So here's the problem. There are some limits that we cannot just directly evaluate. So there's this guy, L'Hopital, French, came up with a rule. So this is what you need to know. When you apply directly, if what you get is 0 over 0 or infinity over infinity, then you're going to have to use L'Hopital's rule. So when you apply 3 times 0 is 0, 0 plus 1 is 1, and then sorry, I got a telephone call. So when you put 0 in here, the natural log of 1 is also 0. So because of this, then you say L'Hopital's rule. So then what you're going to do is, and I think some people do this. Oops. What you do is you take the derivative of the numerator So the derivative of this numerator is 3. The derivative of ln of 1 over x is 1 over x plus 1 ln of e. That'll cancel. Derivative of x is 1. So it's 1 over x plus 1. Okay, now you try the substitution again. Well, this is clearly 3, and then if we put 0 in here, 0 plus 1 is 1, 1 divided 1 is 1. So the limit as x approaches 0, 3x over ln of x plus 1 is 3. All right, let's do a more complex one. So if you plug 0 into here, e to the 0 is 1, because remember, any non-zero number to the 0 power is 1, laws of exponents. All right, so 1 subtract 1 is 0. And then if you put 0 in here, 0 cubed is 0 times 4. All right, so L'Hopital's, you have to do this each time. So I'm okay with just doing L'Hopital's like that. And then, and I think sometimes some just do one limit as x approaches 0, but I think I had a professor do this. Okay, the derivative of e to the x is e to the x, and then the derivative of 1 is 0. And then the derivative of 4x cubed is 12x squared. So now when you put 0 in, e to the 0 is 1. 1 over 0. So think about that. 1 over 0, you think, well, we'd have to do that again. But no, let's pick a number really, really close to 0. That's a number really close to 0. And if you type 1 divide a number really close to 0, I don't know how many zeros I put in there. 6, 1, 2, 3, 4, 4 5. 1, 2, 3, 4, 5, 6. So this number right here is 10 million. Well, the closer you get to 0, you're headed towards positive infinity. So the limit as x approaches 0, e to the x subtract 1 over 4x cubed is equal to positive infinity. Okay, and then I'm just going to, here I'll put each one up on the screen. So I'm just showing you the process. I substitute in 0 and we get infinity over infinity. So then this one is the derivative of the numerator. So 5 times the ln of s. Remember, so that's 5 times the ln of sine x is 1 over sine x times the ln of v, which will cancel. The derivative of sine x is cosine x. So that's where I got 5 cosine x sine x. And then you do the same thing. Ln of the derivative of that is 1 over tangent times the ln of v, which would cancel. The derivative of tangent is secant squared. So that's where I got the numerator there. And then when you plug in, so what I did there is now we want to simplify this. So I changed secant squared to, so this is what I'm doing. I'm taking this, I'm rewriting that as 1 over cosine squared because those two are inverses. I changed tangent to sine over cosine. Okay, and then when I multiply this top and bottom by cosine to get rid of that, then I have to multiply this by cosine. Well, this cosine, well, hold on just a second. I wonder if I can show what I did there. We don't even have to do that. This cosine squared, one of them will cancel with this, and that leaves us with 1 over cosine times sine. And then we simplify that further. So I'm going to multiply top and bottom by cosine sine, cosine x sine x. That's going to cancel. And then that becomes cosine squared. There you go. And now that you get it simplified to this, you substitute in, this is 0 to the right. So you would, plug in something really close to 0 that's positive, and you plug that in, and you get approximately the height of 5. So anyway, let me show you. I think I sent these to you, but you can just kind of see that process. Yeah, I sent it to you. There's another one. Now, some of these, you might have to do L'Hopital's rule twice. Looks like maybe I didn't do any of those. Okay, there might be an occasion where when you plug it in again, you get 0 over 0 or infinity over infinity. And then you just do the L'Hopital's rule again based on the first derivative. You would essentially take the second derivative. Also remember, any number over 0 is positive infinity. If it's a negative number over 0, it's negative infinity. Then if you have 1 over infinity, well, 1 divide a very large number, let's say 10 million, well, that's going to get very, very close to 0. So 1 over infinity, you're going to get very close to 0. Or 1 over 0, you're going to hit positive or negative 1, you'll head to positive or negative infinity. So those are things to keep in mind. All right, that's it for L'Hopital's. Patrick JMT has some good videos, and then watch the Think Well as well.